Welcome back, everyone. In this video, we're going to look at the reactions between carbonyls and amines. In the previous video, we looked at carbonyls and acetals. So we're going to look at amines in this video. So let's start with an example of what we're going to be doing. So remember, amines are compounds with nitrogen. So let's say we draw a carbonyl, simple carbonyl, and we react it with an amine. Now, there are multiple kinds of amines, so I'll show you guys what they look like. NH3, that's ammonia. Then we can have NH2R. Now, in this case, the R means carbon. So nitrogen with two hydrogens and a carbon chain. Then we could keep basically replacing the H's with R's. So how about NH, R2? And then finally, NR3. Okay, and notation we give to these is depending on the amount of carbon chains an amine has, we would call this a primary amine, secondary amine, and tertiary amine. All right, and keep in mind the nitrogen in these cases have lone pairs, one lone pair. So let's see how a carbonyl is going to react with a primary amine. Okay, so in the previous reaction, when it came to carbonyls and acetals, which are an acetal, remember, has alcohols. So we're reacting OHs in that case versus nitrogen with an H. So they're going to be sort of similar. But there's a quick difference almost right at the beginning. With an acetal, the first step was the carbonyl became protonated. It grabbed an H+. Now, amines are different. Amines are more nucleophilic than the alcohol. So it doesn't need to protonate the carbonyl to make it an easier target. It can actually attack right away. So how is this going to work? The nitrogen is going to use one of its lone pairs to attack the carbon of the carbonyl, which is going to push this bond up. So let's draw that out. We're going to have our three carbons. The O is now an O minus. And we have our nitrogen connected with its R group and two H's. Now, because it turned its lone pair into a bond, it actually has a plus. So this is the kind of intermediate you should be getting. Now, we have an O minus and we have a nitrogen with a positive. The nitrogen is going to get rid of its H, and the O minus has got plenty of electrons to grab it. So it's going to take the H, and this bond is going to break back onto the nitrogen to neutralize it. So now we have our OH with one R group and one H. Now, what's going to happen is the nitrogen eventually wants to kick out the alcohol. Now let's think back to Orgo 1. Alcohols are poor leaving groups. They're going to end up with a negative when they get kicked off. So we want to make sure it's a good leaving group. And the way we always used to do that is we protonated the alcohol. So that's what we're going to do. The alcohol needs to grab an H+. Now in this case, it's not going to grab the nitrogen hydrogen again. If it did, the nitrogen would get a negative, and nitrogens with negatives are very basic, and there's a high chance it's going to do some sort of a reaction. So instead, it's going to take it from here, the environment, to create water. And if you remember from Organic Chemistry 1, water is a good leaving group. And so what's going to happen is now that we have this good leaving group, the nitrogen, using its lone pair, forms a double bond which pushes the water out. and we get a nitrogen with the R group, the H, and the plus. Now, in this case, we want to get, again, neutralize the nitrogen. And so something is going to remove that H off of it. It's always easier to take off a hydrogen than it is an R group, which is in this case carbon. But all you need to show is this one bond here, the one arrow there. And we get this. This compound, you should know the name of it. If you have a nitrogen double bonded like this with something else attached to it, we call this an imine. That terminology may come up, so that's something you want to watch out for. And over here, when we had an OH in this group, this is sort of similar to something else you guys have seen, all right, when we did the acetal mechanism. If you remember when we did the acetal mechanisms, at one point we had something that looked like this. An OH, which we have circled in blue, and the OR, which is the thing we're adding. In this case, we don't have an oxygen, we have a nitrogen with an R. This was called a hemiacetal. And with the amine, this version of it, we call it a hemiaminal, because it's similar to the amine version of an acetal, so hemiaminal. All right, and so that's the reaction of a nitrogen when it comes to a carbonyl, and in this case we specifically used a primary amine. The good news is you don't have to memorize these reactions with all the different types of amines. They're actually very similar. If we use the same thing, but instead of a primary amine, we use NH3, it would just be the same thing, but this R would be an H. Like this. Same thing. So that's the benefit of this mechanism, is that they're very similar. If you know one, you will be able to figure out the others. Now let's look at, so that was primary amines and this was ammonia. So let's go to a secondary amine. We'll use the same carbonyl compound. We want to keep things as simple as possible. But in this case, we have two R groups. And they can be any carbons. It could be methyls, it could be ethyls. So we'll keep it simple and leave it as an R, so we can use it for basically anything. Now the beginning mechanism is very similar. The nitrogen is going to attack, kicks this up. Oh, and if you guys want to pause it, feel free to do so and you can try this on your own. So we're still going to get our O minus, our N, with its two R groups, and that H with a plus. So far, so good. It's all the same. Next step, just like before, the oxygen is going to want to neutralize itself. So it takes the H, which also neutralizes the nitrogen. Again, so far nothing's different. Now, next step is we protonated our alcohol, so let's protonate it again. And again, so far everything is the same. Notice that not one thing has changed really. And now we just kick out our alcohol by forming a double bond. And we get to here. Now, if you pause the video, you may have run into a little bit of an issue right at this step. Before, what happened when we used a primary amine or ammonia is we had an extra H to deprotonate to neutralize the nitrogen. H's are easy to take off of nitrogens. Carbon chains are very difficult. So I can't get rid of one of these carbon chains to neutralize that positive. So what's going to happen here? We still have to fix that positive. So when you run into this scenario with a secondary amine, you won't have this issue with primary amines and ammonia because they have that extra H. We're going to look at one of the carbons of the that used to be next to that carbonyl. In this case, the carbon's next to the double bonded carbon of the imine. Or in this case, if it's the positive version, it's called the iminium ion. That carbon has hydrogens. There's there, and I'm only drawing one H on each carbon, but in this case, since they're methyls, there are three. And to keep it simple, we'll just look at one. What's going to happen instead to neutralize this intermediate? This hydrogen is going to be taken off. And the bond is going to fall down to make a double bond here. Now that's going to put too many bonds on this carbon, and so this double bond has to now come up to the nitrogen in the form of a lone pair. And we get this. That is called an enamine. So we have imines, which is the nitrogen is double bonded to a carbon, and an enamine, which is when a nitrogen is bonded to a carbon, and that carbon is double bonded to another carbon. So these are two functional groups you should absolutely be familiar with. Now, one thing to keep in mind about how the enamine forms. Since we're forming carbon-carbon double bonds, we want to make sure that we form the most stable double bonds. So let's say we had this scenario. And let's say we had that. Another carbon sticking out of that carbon to the right. In this case, we can take an H from here or here. If we take the H on the right, this bond collapses down and this comes up. And our double bond would be here. And that single bond wouldn't be there anymore. If we did the other H, this would collapse and this bond would come up and we would get our double bond here instead. We always want to make sure we put the double bond in the most stable spot, positive, and remember, double bonds with more carbon groups on them are more stable. So the red double bond is the one that's going to form. So if the two sides of your iminium ion, when you're trying to form the enamine, are not symmetrical, you always want to form the most stable double bond. So in this case, you would go like this. And now we have our enamine. Okay? Now, what do we do if we want to use a tertiary amine? Well, if you look at the mechanisms we've been doing so far, what happens is the amine attacks and we get this intermediate here, this carbon with four different things coming out of it, an O minus, a nitrogen, and in our case, two carbons, but remember it's used to be a carbonyl, so they could have also been hydrogens. Now, the O minus takes an H from that nitrogen. And then once we have an alcohol, it takes another H plus. Now, what's the problem if we used a tertiary amine? Well, in the case of a tertiary amine, like if I, let's say, did this, we wouldn't have an H for that oxygen to grab. And so we're not going to be able to continue our reaction going forward. And so in the case of amines and carbonyls, really we can only worry about using ammonia, which is NH3, primary amines, and secondary amines. Tertiary amines do not have enough hydrogens to be able to go through with this reaction. So in that case, makes it a little bit easier in the case that you don't have to know how tertiary amines work just because they don't. We can't continue with our reaction. All right, and in the next video, we're going to go into what we can do with imines and enamines. We've seen how amines react to carbonyls. Now let's take a look at what we can do with imines and enamines, and I will see you guys in the next video.